This is the mini lesson for 8.2. So this is about stacking containers. So when you're trying to visualize this, visualize like Tupperware containers that your parents have and how we see that first one takes up a lot of space, but then the next one sits down in it and sits down in it. So we just get a little additional height increase every time we add another container. But we see the entire first container, and then we just see a little bit as each container sits inside. So your job at Storage Pros is to create new boxes to ship to the company's plastic containers. Storage Pro makes all different shapes and sizes of containers. To ship the containers, the lids are removed, allowing the containers to be stacked. Storage Pros wants to design its shipping boxes so that they will hold 24 stacks of the plastic containers without lids in stacks of 24, regardless of the size or shape of the container. The table shows the data gathered from measuring the heights of different sizes of their containers. So when we look here, we have round and we have square. So when we have one round Tupperware container, think of it that way, it's 9 centimeters. The square one's taller, it's 15. When you have two, it doesn't double the size because the containers don't just sit one right on top of each other. They go down inside each other like I was trying to draw here. So it only increased it by a little bit, the height. Here too, again, it increases by a little bit each time. So first question it asks is, what are the variable quantities in this problem? So one thing we have are the numbers of containers, and then we also have the height of the stacks. So number of containers is one variable. Another variable is the height of the stack. Okay, remember I tend to put x's, and these would be our y's. So now it says what quantity depends on the other. So if I try to think about that with these two, does the height depend on the containers or the containers depend on the height? Well, the height depends on how many containers there are. So the height depends on the number of containers. So the height depends, this is my dependent variable, and this is my independent variable. So again, I can go back to tables. X is always my independent, y is always my dependent variable. So now we want to create a graph for each container shape's stack height in terms of the number of containers used. Determine the bounds. So again, I always know when I'm graphing, I like to start at 0. So I'm going to say 0 would be my lowest bounds. So if I have 0 containers, then obviously the stack height would be 0. And then what I did is I looked down here at my graph. There are 10 lines. And looking at the table, I see the table goes up to 7. So 7 and 10 are pretty close. And if I go up here, I see I have to go greater than 16.6. So I'm going to go up to 20 so that both of these are divisible by 10. So I get an interval of 1 and an interval of 2. So my x is the number of containers. So I labeled it, and I'm going up by 1. So 0, 1, 2, again, we're numbering the lines. Going up, stack height is my label. I'm going up by an interval of 2, 2, 4, 6, 8, and at 20. So first we want to plot these points. So what I'm going to do is I'm going to use pencil for the round, and I'm going to use pen for the square so that you can see the difference. So when I had one container for the round, it was 9. 2 of them was 9.8, just under 10. 3 was 10.6. 4 was 11.4. 5, 12.2. And I could finish filling this table in. I see this one up by 0.8. So did this. So did this. And here, so if I go up 0.8, 12.2 plus 0.8 gives me 13. And then I'd have 13.8. So 6 and 13 and 7, 13.8. So if I were exact, this should look like a straight line. It's pretty close. Now I'm going to do all of the square containers. So when I had 1, it was 15. 2 was 15.4. 3, 15.8. 4, 16.2. 5, 16.6. Now again, I'm going to try to find this pattern in the table. So this went up by 0.4, so did this, and here, and here. So 16.6 plus 0.4 is 17, and then 17.4. So 6 and 17 and 7, 17.4. Okay, so now they're asking me, did I connect the points on the graph? Why or why not? I am not going to connect the points on the graph because I can't have part of a container. Okay, so these next several questions we've actually answered from our table already, so I'm going to go through these rather quickly. What's the difference? Remember, difference means subtraction in height between a stack of 2 rounds and 1 round. So I'm subtracting those and I get that 0.8 centimeters. Difference between 3 rounds and 2 rounds. So again, this one I'd have to borrow and I get 0.8 centimeters. Here again, 4 and 3, 0.8 centimeters. And 5 and 4, 0.8 centimeters again. So how does the stack height change when 1 round container is added? It increases by 0.8 centimeters. Okay, now they're going to ask me with the square. So same thing. If I subtract them, the square goes up by 0.4 centimeters. Determine the stack height for 6 and then 7 round squares. We did this already in our table. Determine the height of each stack of round containers. Show your work. So what's the height of 10 round containers? So we just said the first round container, when I look at that, I see all 9 centimeters. But then that second round container goes in here and it only increased the height by 0.8. And then when the next one went in, it only increased the height by 0.8. So the first container was 9 centimeters. Each additional container was 0.8. So if we want 10, that means 9 of means times, of the containers were 0.8, plus that first container was 9 centimeters. So if I multiply these, I get 7.2 plus 9 equals my total. When I add those together, 16.2 centimeters would be the total for 10 round containers. What's the height of 15 round? So again, the first one is going to be 9 centimeters, but all the rest of the containers increase by 0.8. So if I have 15 total, that means 14 of the containers are 0.8. So if I multiply 14 times the 0.8, I get 11.2. And this equals the total. When I add those together, 20.2 centimeters would be the total height if I had 15. Okay, if I had 20, remember again, the first one is 9 plus the rest of them. So if the first one is 9, the rest, 19 of them, are 0.8. So if I take 19 times 0.8, I get 15.2. And if I add these two, 24.2 centimeters be my total. So explain how we calculated it. I took 9 centimeters for the first container plus I took 0.8 times the remaining containers. And that equaled the total height. So what does the expression r minus 1 represent if you use r to represent the number of containers in the stack? So think of what is this r minus 1? So in every case here, when I had 10 round containers, 10 minus 1, 9 of them were the 0.8. When I had 15, only 14 of them were 0.8, 15 minus 1. When I had 20, 19 were 0.8, 20 minus 1. So if r is the total number of containers in my stack, r minus 1 is the number of containers that increase the stack height by 0.8. Because remember, that first container is 9 centimeters. All the rest, all the containers are, minus that first one, are the 0.8. So we're going to use some letters. We're going to let h represent the stack height. Well, that's what I'm finding. So the height is equal to, I'm going to write an equation, it has an equal sign, that represents the stack height of round containers in terms of the number of containers in the stack. So just like we were doing up above, the first one is 9 centimeters. That's constant. That always is going to be the case. Plus, it is 0.8 times every container, but not the first one, because the first one was 9. So this would be the equation that I could use.